Have you ever looked up at the night sky and seen a super bright star, one that doesn't twinkle like the others? Chances are you were looking at a planet. And very often, that bright, beautiful point of light is Venus. For thousands of years, people have gazed at Venus, calling it the morning star or the evening star. It's so bright and beautiful it's named after the Roman goddess of love and beauty. But don't let its pretty face fool you. Beneath its shiny cloud tops lies a world of incredible extremes. A place so wild and hostile it makes our toughest environments on Earth look like a walk in the park. When scientists first started studying Venus, they got really excited. From a distance, Venus looks a lot like Earth. That's why it earned the nickname Earth's twin. Let's start with the basics. Venus is the second planet from the Sun, while we are the third. This makes it our closest planetary neighbor. Sometimes it gets closer to Earth than any other planet. It's also very similar in size. If Earth were a basketball, Venus would be just slightly smaller, like a volleyball. They are almost the same size, which is pretty rare in our solar system, from tiny Mercury to giant Jupiter. Beyond its size, Venus also has a similar mass and density to Earth. Get ready for some mind-bending time travel, because time on Venus works in a very strange way. On Earth, we know that a day is about 24 hours long, and a year is about 365 days. A day is how long it takes for the planet to spin once on its axis, and a year is how long it takes to orbit the Sun. But on Venus, this whole concept is turned completely upside down. A single day on Venus, meaning one full rotation, takes 243 Earth days. That's incredibly slow. Imagine the Sun staying in the same spot in the sky for months at a time. Now, let's talk about a year on Venus. Because Venus is closer to the Sun than Earth, its journey around the Sun is much shorter. It completes one full orbit in just about 225 Earth days. Now, let's put those two numbers together. Do you see the puzzle? A day on Venus is actually longer than its year. You would celebrate your birthday before a single day-night cycle was even over. If you thought the long days on Venus were strange, wait until you hear about its atmosphere. It's the single most important feature that makes Venus the hostile world it is today. The air on Venus is not like our air at all. It's incredibly thick and heavy. In fact, the atmospheric pressure on the surface of Venus is over 90 times greater than the pressure we feel here on Earth at sea level. Imagine diving nearly a kilometer, or over half a mile, deep into the ocean. That crushing pressure is what you would feel just standing on the surface of Venus. Any spacecraft or probe we send there has to be built like a military-grade submarine to avoid being instantly crushed. What is this super thick atmosphere made of? It's definitely not the friendly mix of nitrogen and oxygen we breathe. The air on Venus is about 96% carbon dioxide. Carbon dioxide is a powerful greenhouse gas. On Venus, that massive CO2 created a runaway greenhouse effect. It lets sunlight in but traps the heat so it can't escape back into space. For a long time, the surface of Venus was a complete mystery, hidden beneath its permanent blanket of thick, swirling clouds. We had no idea what lay below. It wasn't until we started sending spacecraft equipped with powerful radar that we were finally able to map the surface and reveal the dramatic landscape hiding underneath. What we found was a world shaped by intense volcanic activity. The surface of Venus is covered in volcanoes, hundreds of thousands, maybe even millions of them, more than any other planet in our solar system. The landscape is dominated by vast, rolling plains of solidified volcanic rock, similar to the basalt rock that forms our own ocean floors. One of the tallest mountains on Venus, Mont Mons, is an enormous volcano that stands about 8 kilometers, or 5 miles high. Scientists are particularly interested in volcanoes like this one because there is evidence that some of them might still be active today, spewing lava and volcanic gases into the thick atmosphere. One of the most mind-boggling facts about Venus is the way it spins. Nearly every planet in our solar system rotates on its axis in the same direction, including Earth. If you were to look down on the solar system from above the Sun's North Pole, you would see all the planets orbiting the Sun counterclockwise, and most of them would also be spinning counterclockwise. But Venus is a rebel. It spins clockwise. This is known as retrograde rotation. This backward spin has a very strange effect on the planet's day. If you could stand on the surface of Venus and survive the extreme conditions, You would see the sun rise in the west and set in the east, the complete opposite of what we experience on Earth. So, why does Venus spin backwards? Scientists have a few leading theories, but no one knows for sure. One popular idea is that early in its history, Venus was hit by a giant asteroid or another planet-sized object. A massive impact like that could have been powerful enough to not just slow down its original spin, but to completely reverse it. It would have been a catastrophic event that forever changed the planet's destiny. Exploring Venus has been one of the greatest challenges in the history of space exploration. Its hellish surface conditions mean that visiting is incredibly difficult. Probes and landers have to be built to withstand crushing pressure, searing heat, and corrosive acid. Despite these challenges, humanity has been sending robotic explorers to Venus since the 1960s, making it one of the first planets we ever visited. The Soviet Union, in particular, led the way with its ambitious Venera program. In 1970, their Venera 7 probe became the first spacecraft to successfully land on another planet and transmit data back to Earth. The Venera missions were engineering marvels. These tough spherical landers were designed to survive the intense journey through the Venusian atmosphere. Later missions in the series, like Venera 9 and Venera 13, did something even more amazing. They sent back the first and only images we have from the surface of Venus. Black and white pictures. Later, color pictures revealed a rocky, desolate landscape under a gloomy, orange sky. The landers didn't last long. The longest survivor, Venera 13, transmitted data for just over 2 hours before succumbing to the heat and pressure. The exploration of Venus is far from over. In fact, a new era of Venus exploration is just beginning. In the coming years, NASA is planning to launch 2 new missions, Veritas and Da Vinci Plus. Veritas will create incredibly detailed 3D maps of the surface. Da Vinci Plus will plunge through the atmosphere, analyzing its chemistry and taking pictures as it descends. These future missions will use cutting-edge technology to answer some of the biggest remaining questions about Venus. Beyond its major features, Venus is full of fun and surprising facts that make it even more intriguing. One of the first things people notice is its incredible brightness. Venus is often called the morning star or evening star because it outshines every other star or planet. Another surprising fact: Venus is hotter than Mercury. Mercury's sun-facing side gets very hot, up to 430 degrees Celsius. But Mercury has almost no atmosphere, so at night it plunges to minus 180 degrees Celsius. Did you know it might snow metal on Venus? It's not the fluffy stuff we know. Deep in the atmosphere, metals can vaporize and exist as gas. Higher up on mountain peaks, where it's slightly cooler, these metallic vapors could condense and fall as frost, coating the peaks. This could be a thin metallic snow layer, possibly lead sulfide or bismuth sulfide. And what about the weather? While there's no rain on the surface, the upper atmosphere of Venus is a wild place. It experiences incredibly powerful winds whipping around the planet at speeds of up to 360 kilometers per hour, much faster than the planet itself rotates. And within these fast-moving clouds, there are powerful lightning storms. Unlike Earth's lightning, which is associated with water clouds, Venusian lightning is generated within clouds of sulfuric acid. After learning about this hellish world, crushing pressure, extreme heat, and acid clouds, you might be wondering, why should we care? The answer is simple and incredibly important. Studying Venus is crucial for understanding our own planet, Earth. Venus serves as a giant cosmic laboratory, showing us what can happen to a rocky, Earth-sized planet when things go very, very wrong. It's a cautionary tale written on a planetary scale, and it holds vital clues about planetary climates, including our own. By studying how and why this happened to Venus, we can learn invaluable lessons about the delicate balance that makes Earth habitable. The runaway greenhouse effect on Venus is a perfect, if extreme, example of what happens when a planet's climate spirals out of control. On Earth, we are currently adding greenhouse gases like carbon dioxide to our own atmosphere at an increasing rate. While Earth is not at risk of becoming another Venus anytime soon, studying Venus helps us refine our climate models and better understand the long-term consequences. Ultimately, exploring Venus is about more than just satisfying our curiosity. It's about understanding our place in the universe and the factors that make a planet capable of supporting life. By comparing Earth to its evil twin, we learn what makes our world so special and fragile. That bright, beautiful star in our sky is not just a pretty light. It's a mirror reflecting a possible future, a powerful reminder of the need to understand and cherish our own unique and precious world.